my name is Liz Alagai-Glomset, and I work in the Education and Youth team at London City Hall. And I'd like to welcome you all very heartily on behalf of the Mayor of London to this third session in our STEM webinar series. And it's really fantastic to have so much interest in primary computing. Really, we have people from all over the country, and a warm welcome to you all. Have to say, particularly strong showing from Harris Academy on Philip Lane, which is literally down the road from me. We have about 10 people signed up, so amazing. As there are so many of us, I just have a couple of things to ask you. Please, can you keep your microphones muted? Feel free to ask questions and use the chat or email me for that. And Sharifa will answer after the presentation. And I will send you the slides, and the session is being recorded, and that will be made available to you as well. So some of you may not be able to access the chat. I think I warned you in my email. This happens if you're joining directly online without logging into your Microsoft or Office email account. So if you have questions, do email them to me. You have my email address in your inboxes, you should do, and I'll also send an email afterwards with all the relevant links that you need. So lots of you will have told me actually that you've heard about the webinar through a colleague. So I'd really recommend you to sign up to the London curriculum so that you won't miss any emails and invitations to webinars and events and other opportunities for teachers. You'll also get access to a huge library of free teaching resources for Key Stage 2, and that's all free from the Mayor of London. So I'm going to pop that in the chat, and there is the link to sign up. I'll, like I said, circulate these links later as well for those of you who can't see it. The other thing is, if you're a primary school in London, it's highly likely that you're eligible for a voucher from the Mayor of London to get Crest Awards fully funded. So definitely check if you're eligible. Here's the link for that. And we have another webinar coming up in 1 week. Little bit short notice because of schools opening again. And it's a follow-on from the previous webinar we had on planning and assessment in primary science. And this next one is about how to differentiate effectively in science. And that's a topic that a lot of the attendees at the last one requested. So here's the link for that to sign up. Right, so I'm going to hand over to our facilitator. That's Sharifa Khanum from the National Centre for Computing Education. I hope you find the session really useful and that you enjoy it. And thank you very much. Over to you, Sharifa.
Can you hear me, Liz?
Yes, can hear you. Can't see your face though.
Okay, fab. Brilliant. So, thank you very much. Hello, everyone. Thank you for the introduction, Liz. So just a quick, brief background info about my experience in education and technology. I was a secondary school teacher, AST computing teacher for 8 years in London. And for the last 5 years, I've been working as a consultant supporting both primary and secondary with computing and online safety. And I was a programmer and a web journalist before that. So our session aims. We've got 4 session aims. The first one is exploring the 3 strands of the curriculum, considering what kinds of activities fit into each, how to best support pupils to develop computational thinking skills, teaching the big 3 programming concepts of sequence, repetition and selection, explore the wealth of resources, support and fully funded CPD available from the NCC. Please do not worry if you aren't familiar with the 3 strands of the curriculum. This will be explained within the session. Hopefully everyone has been able to access the resources. I did put it on the chat and someone has been kindly reposting it for others as well. So thank you so much, but you can also access the resources using the QR reader if it makes it easier, especially if those people haven't been able to download Teams as well. I'll just give you a moment here just for a few people just to open that up, because I will be asking you through the session to open up the materials, and we'll be doing some activities. Okay, so why computing? Why is it so important for our pupils' future life opportunities? These are some of the reasons why computing skills and knowledge are important for individuals and for a wider society. I will pause and just let you read some of the statements on the screen as opposed to me just reading it to you. Thank you. We are going to be sharing this presentation with you afterwards, so please do stop me if I'm going too fast, or let me know in the chat, even though actually I can't see, but Liz can let me know if you want me to go much slower. I've got a Scouse accent and I do talk quite quickly at times. So the transition from ICT to computing, the new word, the word new, sorry, is inverted in commas, because although the National Curriculum for Computing was introduced some time ago in 2014, many teachers are still getting to grips with how to teach the subject effectively. This has mainly been due as a result of low teacher confidence and the lack of initial government CPD opportunities and training to equip teachers adequately enough to deal with the subject change in direction. Just to note, though, that many businesses still do use the term IT information technology. So why did this happen? Why was there a shift from ICT to computing? This report, the shutdown or restart by Royal Society, was undertaken in 2012, and their quote actually had the title quote from the author was ICT in schools should be shut down or restarted. And they put in as well in the report that the subject ICT failed to provide a deeper understanding of the rigorous academic subject of computer science and exposure to opportunities of interest, excitement and creativity that even a modest mastery of the subject offers. Again, this report, I think I've added it into our resource document, but if not, I will check it again, but I'll add that in, make sure. So what are the main changes? The obvious one, obviously, is the name from ICT to computing. There's a greater emphasis on computer science. There's higher expectations, children expected not just to do, but also to understand. Significantly more and harder computer science objectives, and a familiarity of new vocab such as the algorithms, debugging, variables. There's also an increased emphasis on unplugged activities in which students work away from the computer. This encourages computational thinking that involves logic, problem solving, analysis of patterns. So the key components of computing are split into three areas, which are called strands. I'm going to ask you to open up our session materials document right now, and if you could click on row number 2 and select the link, which will open up a Jamboard. So I've put the print screen in front of you there, so row number 2, and open up the Jamboard. If there is people who are unable to open the Jamboard, you can also participate by clicking on the chat box, and what I would like you to do is I would like you to name one key strand from the computing curriculum and add it onto the sticky note on Jamboard, or you can add it onto our text chat as well. So I'll just give you a moment to just catch up. Please don't feel pressurized that you have to know this, because I know from some of the participants might be absolutely new to computing, so add anything that you've got in your head at the moment in terms of the strand. This is the bit where I'm going to hop off this presentation and go in live into Jamboard and see what we've got. I'm hoping you can still see my screen. Yeah, fab.
Sharifa, sorry, I think there are currently too many people using the file.
Oh, right, for the Jamboard?
Yeah, it looks like
you can go to number 2 as well, Jamboard number 2. So on the top here, you can click on Next and select here too. So I've put 2 there for you, and you can also use the chat tool as well. So just going to have a look.
Can I check that those of you who can't see the chat, that you're able to access this? Okay, let us know if not.
Thank you for the person who's moved the document to the side to make space. It's really great. Yeah. Digital literacy seems popular. ICT. IT. I'll just check on number 2. Yeah, you can use this one too if you wish. Jam 2, it's on the top, so you just click on the left, right. Okay. Thank you. We're going to keep these jams, Jamboard and all the jams on here, so you can go back to it. It'll be also really interesting for us to keep a record of these answers as well. So if we go back to our presentation, thank you very much for your contribution. 3 strands are computer science, IT, information technology, and digital literacy. Be aware that these are not explicitly organised into these 3 areas within the national curriculum itself. Most specialists and practitioners agree that the objectives
I'm going to have to queue for the COVID test before the
categorised into these 3 distinct areas. So Miles Berry, he's principal lecturer in computing education at the University of Roehampton. He's contributed to a number of projects, including the computing program study, and he provides actually a really useful analogy. Computer science is the foundation of the subject, i.e. the underlying principles that make up the subject. IT, information technology, is how you would apply this knowledge and understanding to purposely create and make things. And then digital literacy is about considering the implications of how you're going about doing this. And also, just to bear in mind, I know most of you will be aware of this, but digital literacy is not just online safety, although aspects of this do come into it. So these are the program of study, computing program of study statements from the Key Stage 1 statements. I've provided the link of the program study within our session documents as well. It's the first one there, and it's also on the Jamboard too. I've got in front of us, we've got 6 statements from Key Stage 1. I would like you to match the strands to the statements, but this is just for your own reference. I'm not going to ask you that you must put it onto the chat, but if you are confident, I would like anyone who is confident to add in the strand that they think would be the IT strand. Which one out of those, or a few, do you think will be the IT strand? And if you could post into the chat, that'd be really useful. Okay, brilliant. Okay, and have a go at the other strands too in your see if you would be able to identify 1 and 2, 6, a few of the others before I move on and reveal. Okay, thank you so much. Yeah, brilliant. Absolutely. So you can see computer science are strands 1, 2, 3 there on the top, and then information technology is 4. Use technology purposefully to create, organize, store, manipulate and retrieve digital content, and then digital literacy 5 and 6 strands. It could be also argued that the 5th objective does cover elements of all 3 strands. And the purpose of this activity is just to provide a general guide as to where each object might fit within the 3 areas. And although this is important to know, it's also very important that the coherence in the actual teaching is more important than being able to label every single strand within the area of the computing that it covers. And also it's really interesting to notice that 6 objectives in the key stage 1, 3 out of the 6, 3 are computer science. So we'll move on to now the key stage 2 program of study. This time I'm going to ask you to open up a Google Forms. It's on our session materials. If you could open that up, and it is under number 4. Okay, so it's a Google Forms number 4, and I'd like you to match the strands with the statements. And I am going to hop off and go live into Google Forms just to see some of the responses. Okay. Let's have a look. Okay, so this is the Google Forms. Please, if you aren't able to access Google Forms, please do try just within yourself, just look at the statements. I'm going to go back to our presentation so you can see it, and then what you can just do is jot down which strand you think would come under computer science, information technology and digital literacy. So I'll hop back onto our presentation screen. Brilliant, I can see 34 responses. Yeah, going up. Fab. Okay, so you can, I think I'll give you another 30 seconds or so before we move and reveal which strands fit with computer science, IT and digital literacy. So we've got about 44 responses now. Right, so I'm going to reveal which strand goes with which, and I'd like you can just check with your answers yourself. So you can see, again, the top 5 is the computer science, and then the middle, number 6 is IT, and number 7 is digital literacy. This gives a general overview of which strand of computing each objective is roughly aligned to, and it's really worth noting that the simplicity of the computing program study, 2 pages. It's only two sides, 1 page, 2 sides. So the simplicity of the computing program of study rather than the English program of study or the maths with dozens of pages each, it's really useful. It gives teachers that flexibility to deliver the curriculum in different ways. So other consideration, what else is important in my teaching of computing? This is something that I didn't put in within the session objective, but I thought it'd be really useful for us to discuss the Ofsted framework and the implication this has, the new Ofsted framework this is. So the inspection framework focuses very much on coverage across school on all curriculum areas, not just maths and English. Ofsted inspectors will probably want to know what is being taught, how are you teaching it, how this builds on skills taught in the previous year groups, i.e. progression across the whole school. These questions could be asked even if you haven't been selected, you haven't selected computing as your deep dive focus. So it's just worth bearing in mind. And obviously I can't, you know, during these short sessions, we can't go into too much detail, but I didn't want us to have an introduction to computing without talking, at least referencing the new Ofsted framework. So breadth of the curriculum, what kind of things should I be teaching in order to cover the curriculum requirements? Again, I've got a few activities. This one you don't need to interact with, just want you to open up this Padlet. It's on number 5 of our resources material, and I'll show you. It looks like this when you open it up, and basically this is completed, it's a Padlet of completed computing projects pupils in one school have been involved in, and the link is on number 5. Please do go on now. I'm going to give you about 3 minutes or so just to go in, have a look, open up each of those Padlets, have a look at what activity they have completed and what coverage it was from the computing program of study. Really useful to have that a moment to look at other schools, what they are doing and coverage of the breadth of the curriculum. So I'll pause here for 2-3 minutes or so and let you explore this Padlet. I'm hoping everyone has been able to access the resources, but again, if you haven't, maybe afterwards Liz will be able to, when we share the presentation, we'll be able to share the link to these as well.
I'll do that, Sharifa. Also, if any of you who aren't able to access the resources document because you can't see the chat, sorry this took so long, but I have put the link into the Eventbrite for this CPD, so you can go on there and get the link from there.
And there's the QR as well for this, so if you've got a QR reader, you can use the QR reader as well.
That's a good point. Thank you.
Thanks, Liz. Okay, hope most or everyone have had an opportunity to look through the Padlet and some of the activities. It's worth noting that, you know, the school, they would have planned these activities as sequence of learning designed by the school. It's also worth, you know, noting down that it has to fit in the wider context of their own teaching and not just a series of one ready-made lessons that they follow, you know, rigorously without thinking about how it might best fit for them. And it's something that we as computer leads or in schools or primary school teachers need to ensure as well. So different schools may also have different names for sequence of learning as well. But however, every school should have a plan that allows the activities or lessons to be linked over a period of time. Hopefully that was useful for you. Again, remember you can access these and go in a bit more detail as well. I work very closely to the person who works in this school. So if there's any questions that you want to know more information about, I can certainly, you know, pass your information over to them as well, and they'd be more than happy. Oops. Okay, so sequence of learning, we mentioned that in the previous slide. Different schools have different names. Sequence of learning, essentially this means the order you choose to teach your curriculum, why you teach, what you teach, when you teach it. However, every school should have a plan over a period of time. It's also very important that you think about the wider context, the activity, and that you ensure that you do cross-curricular where possible as well. Okay, it's not enough to have done some programming. We need to know what that our children learn each year, and it's built on from the previous year or previous unit and what went on before. And an important question to ask for each topic or unit, I think, would be, what do we hope our pupils will remember for future teachers? That's a really good question I use for myself when I used to plan a lot in secondary and in primary. What would I want from this unit that they should remember for their future teachers or for the next unit? So Key Stage 1, these are the programme of study statements that refer to the objectives based around just computer science for Key Stage 1. This isn't the whole programme of study because we've looked at the whole programme of study. Note how each objective refers to the word programming and not coding. Key Stage 2. Again, objectives for Key Stage 2, and again, it's just for the computer science, and the terms programme is referred to within each objective apart from the final one, covering around understanding of computer networks. So what do we actually mean by programming? What do we actually mean by programming? Both of the Key Stage 1 and Key Stage 2 programme study reference these words, programs and programming, really frequently, but do we know what it actually means? This is a good way of understanding it. A programming which could be seen as a two-step process. First, you can see on your screen the diagram on the left, design. Design is created, including an algorithm. The algorithm includes the steps or rules a computer would need to follow in order to complete the task. The example here uses the algorithm takes the form of a storyboard. Then once that algorithm has been developed, it then needs to be implemented in a language that the computer understands. This is called coding. This is called coding. In this session, the programming language we are going to use is Scratch, or I'm going to reference Scratch, but an algorithm can be implemented in different languages, not just in Scratch. And most of you probably in your school use different kind of languages within your school setting, not just Scratch itself. So computational thinking, the opening statement of the national curriculum puts computational thinking at the heart of it, the heart of computing. This is not thinking like a computer, as computing devices are inanimate objects which operate through following instructions provided by humans. Computational thinking is a set of critical thinking skills that, whilst most important for computing, also has a much broader significance. These can be developed in a variety of ways through use of unplugged activities away from the computer to do more formal programming. And also computational thinking is relevant to all areas of the curriculum, not just computing, especially, I would say, maths. So algorithms. Before pupils can learn how to program, they first must be able to read and write algorithms. So it's step-by-step instructions are key for all algorithms. Precision is also very important when creating algorithms that will then have to be turned into code, or those that humans or a system will have to follow. The next few slides, I'm going to give you some examples of some introductory ideas of young people being able to become more adept at writing these algorithms. So this is quite a nice, some of you would have who've been teaching primary a lot would have probably recognised this poster. It's created by Pete Dring and it's on CAS. So when teaching pupils about algorithm, it's good pedagogy to try and give real life examples to draw upon in order to better secure their understandings. A good example, again, lots of primary school teachers will have done this. Recipes, they're really great for good examples of algorithm. Also, teachers should look for links with other curriculum areas, such as maybe instructional writing within English, or dance routine within a PE or dance, etc. Okay, and you can download those posters. I'm going to use quite a few of them. So unplugged. So I'm going to ask you to another activity. I feel like I've talked a lot here the last few slides. So I'm going to ask you to do an activity. It's going to be an unplugged activity. I'm going to ask you to open up, if I just go, our number 6, resource number 6, and we are going to create a crazy character. And I'm going to give you some instructions. They're up on the board already, so I'm going to reveal them all. There you go. There's 5 instructions, and you need to create a crazy character. Okay, so opening up number 6 will take you to Jamboard, and I would like you to go to Jamboard number 3 or 4. Jam number 4, 3 or 4. Open it up, and you can start drawing this character that I've got the instructions for. People who haven't got access to the Jamboard because of the access to the course list, please do this on a piece of paper, pen or paper. I just thought it'd be really nice to see what crazy characters you all come up with on the Jamboard. So I'm going to hop off here, and I'm going to go on to Jamboard so I can see the live drawings. Okay, and this is where you need to go on to 3 and 4 Jam. So you just click right, and you can start drawing around anywhere that, on the Jam. And you can use the pen as well tool there. So I'm going to hop off and have a look at what you're up to. And for the people who aren't going to access Jamboard, please do write the instructions on a piece of paper. Okay, let's see. Oh God. Wow. I feel some of you knew what this, some of you uncannily is similar to what I've got. So you've done this before. It's brilliant. I'm actually going to record this a bit while you're. So I'll give you another 30 seconds, I think. Okay, brilliant. Okay, and you can use, oh yeah, look at that. Okay, I'm going to hop back onto our presentation. So if we had time, and usually these courses are face-to-face, I would have made you redo those characters, but I would have made sure that I'd given you more detailed, precise instructions that you could draw something similar to the one I've got on my screen, because that's what it's supposed to look. Okay, so if any of you do have one similar, I'm going to go back to the Jamboard later on and have a look. If any of you do have one that's similar to that, I think you've done this activity, or you're very good. So you can see in the orange are the added detail of instruction from our first instruction that I gave you. So again, this is a really great activity that you can do with your pupils as an unplugged activity, and you can get the full resource from Barefoot, and I'll be introducing Barefoot later on towards the end of the session as well. Thank you for that contribution. It's really great. Unplugged activities have the most impact when actually the pupils can see the link between what they are doing and are then given the opportunity to apply this to real programming. So you can see the example up above there, writing an algorithm on a whiteboard or using a pre-made algorithm cards to work out how to get the Bee-bot. I think most of you recognise those are Bee-bot, those bumblebees there at the bottom. Bee-bot, how to get to a predefined destination, or perhaps you can use a human bot to test, run the different algorithms that you might come up with to get Alex the robot to the end tile of the Alex iPad app as well. So you can see the example on the far right. So human bots are really useful for unplugged activities as well. And you can get more of these resources. I've referenced them on the slide from Codit as well, and also again Barefoot. So programming and program in terms of sequences, repetition and selection. There are 5 main programming concepts referenced within the computing program of study. We're going to cover these in the next slide, which we're going to cover 3, and we're going to explore sequencing, repetition and selection, and then we're going to use Scratch 3 as well to showcase those. So these are the 5 in the diagram reference point to the programming concepts. There is some agreement between primary programming specialists that these programming concepts are in order of difficulty, as you can see there, especially in limited ways we tend to use them in primary schools. However, I need to point out there's very little research that confirms or denies this. So I've selected for us, we've got sequence, repetition and selection, like I said, that we're going to cover during this session. So can I ask participants to work out, I've got 3 Scratch blocks in front of you. If you, most of you will probably perhaps recognise they're Scratch blocks. We've got 3 in front of you. What I would like you to do is I would like you to select which code would draw a square. Which one, if I ran it, would draw a square. Okay, and you can type your answer into our chat box. You don't need to go anywhere, or you just can write it somewhere on a notepad. I'm just going to give you a moment just to go through, because there might be some people who've never used Scratch at all, or totally new to Scratch. So I would suggest looking through each of the blocks within that and instructions within the blocks, and just reading through and one at a time and seeing in your head what would happen, or taking notes down. Okay. At the moment I can't seem to see the chat, so I'm hoping most of you have put down B. Is that right, Liz? I can see you though. Yeah, B. Yeah, fab. Can I also ask which one, and you can write this in your chat as well, what part of the computational thinking, what part of computational thinking is being used here? Which part? Okay, yeah, okay. Logical thinking. Fab. Okay, I'm going to move on. Thank you so much for your answers and contribution. So this is a diagram, a simplified version on a strategy used by Irene Lee and colleagues in a paper in 2011, and it's called Use, Modify, Create. The idea behind this is that the learner uses an existing program to use what it does, then they modify it, and then when the understanding is pretty secure, they are able to then create a project of their own. So the next few slides, we're going to hopefully use some of these basic, in the basic activity ideas, we're going to hopefully cover some of these key programming concepts mentioned within the program study, and consider ways in which we can fit these ideas within this framework of this model. This is to give you some practical ideas that you can take away and put into practice, but at the same time, it's really important to consider how to teach programming concepts effectively, as well as what to actually teach. And this approach has been proven to be really effective pedagogy. Sequence. For those, again, like I said before, new to Scratch in general, or specifically Scratch 3, that is the latest version now, Scratch 3, from I think it was last year. And sequencing. A sequence is a specific order in which instructions are performed within an algorithm. So this is an example here, and I've shared this link on our course materials that you can access later on and use as well. So, you know, pupils can create a design, an animation using a storyboard. The algorithm can include what you will say. You can add some more boxes if you like, then implement the algorithms as code using Scratch. So again, this is a really useful way of sequencing. This is another example, follow on from that one. You can use, again, I've added that into our resource list. You can see there it's broken down. If this was animation, for instance, this one's an example of Little Red Riding Hood. You can see, oh, sorry, there, Little Red Riding Hood. You can see there, and it's got two sprites, two characters, Little Red Riding Hood on the left and grandmother on the right, and it's a sequence of animation of them having a dialogue. Okay, and again, really great way of starting for pupils to start thinking of their algorithms or partly made algorithms, and then for them to implement and test and run. I've shared this project with you. This is the Little Red Riding Hood project with you. This has already the codes, blocks within it, all laid out for them to then assemble together and have a sequence of instruction sequence, and really useful to have blocks ready for the pupils instead of them going in blindly and selecting blocks that they may not necessarily be confident in. So pupils then can test out their algorithms on the two sprites to see if it works. Again, all shared on your resource material. Cross-curricular application, important to give pupils opportunities to extend and apply their learning further through creating their own longer-term projects. This can help pupils, give pupils a real sense of purpose, I'd say, and encourage ownership of their work. Linking computing to other subjects, curriculum topics in this way has many benefits. So history, an example, code the dialogue between two main historical figures. MFL, how about asking pupils to program a conversation in a different language? And Scratch also has Scratch Online, not the downloaded version. Scratch Online has a built-in translation tool, which is great. English, code the key dialogue from two important characters within the text you are currently using in class. I wish we had time, but this would be a great opportunity to say what ideas can you think of within your class for cross-curricular. So if we move on now to repetition. So repetition means repeating a sequence of instructions a certain number of times or until some specific result is achieved. Okay, so here I've linked this in our resources document, is an example of a dancing monster, and you can see there they would write the space for algorithm to be written down, and an example algorithm as well. Again, you could have let them write the algorithm and then have on the Scratch project itself the blocks or part of the blocks with the loops or repeat there. You can see the loops in there, and then get them to create it, put them together and explore individually. So they record that algorithm first on that Square document itself and make sure then they test it out on Scratch. It's worth noting, if you can see on your screen right now, that there is 2 repeat loops and a forever loop, and the first, if I go back here, they're kept separate, and we've done that on purpose, so not just to avoid cognitive overload, so it can be quite demanding, so keeping it separate so it's easy for them to get it together. And also it's worth noting this example has a nested loop within our overall forever loop as well. So again, I apologize, there might be people who are very new to Scratch, but I have put this project in the source in our course material, so do have a look, open up the project and play about. That's the best tip I could give you, play about with Scratch. If we move on now to selection. So selection is when your program has to make a choice. There will be different terminology depending on specific programming languages used. And I've also put a link on the source material and a link on this presentation to a selection example project as well. So if we look at this one. So within Scratch, the language of if, then else is used for selection. So I'm going to ask you what you think, or actually the condition where you think, you don't need to, you can just jot it down on a piece of paper, you don't need to put it on the chart, just for your own reference, where the condition would be. Yeah. If it is raining, then what happens if the condition is met and it's true? Take an umbrella. What happens if the condition is not met? False. Don't take an umbrella. Really great way before pupils move on to Scratch and start using selection, the if then else, for example, have it unplugged just like we've done here. Have a few selection of unplugged where they're using it in the correct way. Another example, this is really a nice example with in terms of selection on a Scratch project. So this project, when the programs run, it's a question that poses, and what's 9 times 5? And if the player responds with the correct answer, it'll say well done, that is correct. If they respond with the incorrect answer, it says incorrect. It would be really useful if you've got time to go in and have a play with that later on as well, especially if you are new to using Scratch. Debugging, I think this is a word that you know, is becoming really familiar within primary computing now. The best programmers test their code frequently for any bugs. That was one of my main jobs when I was as a trainee programmer. It makes it easier for them to identify where the errors may be within their code. The skill of debugging should be continuously modelled by the teacher so that the pupils know what it looks like and are therefore able to apply the skill as an automatic process within their work as well. So it's almost like an assessment activity, I think. I'm going to ask you to look at the 3 codes in front of you, A, B and C. and I'm going to ask you for A, if you could put down in the chat box if you think A is an example of sequence, repetition or selection. So put in the chat box A and whichever one of those three. Sequence, repetition or selection. I'm not going to give the answer, we'll move on, because if I start giving you, it'll eliminate the other ones. Okay, so B, for B, can we put in if it's sequence, repetition or selection? And can we do the same with C, please? Okay, so I'm hoping most of you have got A as selection and B as sequence and C as repetition. Okay, brilliant. So further useful resources. I am going to go through courses on offer from NCC, but a follow-on would definitely be a course called Primary Programming and Algorithms course, which will go into more in-depth, you know, the sequence selection and repetition, as well as variable and amongst other things. So again, we will discuss the offer from NCC later on. So the bigger picture. Does it matter that you don't know everything? Do you have to be a theologist to teach RE, for example, or a mathematician to teach maths, or a physicist to teach science? For a variety of reasons, I think practitioners often approach the teaching of computing differently, but should our attitudes actually towards this subject change in any way from other subjects within the curriculum? So you can see there how pupils learn, you know, how to sequence progressive lessons, important, how to present you information in a variety of ways, how to diagnose and misunderstandings, how to give children opportunity to apply their understanding, support all learners, and the last bullet point, a better understanding of computing curriculum, underlying principles of computational thinking, and some practical experience of teaching programming effectively can be covered by courses that you can attend, such as the NCC courses or other courses on offer, and resources as well. But absolutely, you don't have to have a first in a computer science degree. So if we look at this question here, what is the greater achievement? Writing the instructions to build the Lego model, which is on the left, or actually building the Lego model itself? So if we refer back to key messages, many would probably argue that the person who designed these instructions have actually achieved a greater accomplishment here, because without these instructions, that Lego creation would not have even been built or not be successful. And again, this is quite nice for pupils to be able to, an example like this, worthwhile for pupils, because sometimes they do get bogged down with seeing the end product, but actually their achievement getting to it is very important. So your support networks, where can you go for support in terms of computing, teaching computing or leading computing? So what is the NCCE? NCCE is a consortium of STEM Learning, Raspberry Pi and BCS. They both, all three, sorry, make the NCCE, and it was launched in 2018, funded by the DFE. And the vision is for the NCCE is for every child in every school in England to have a world-leading computing education. What they offer for primary school computing primary school teachers and courses are here. We've had to change these most recently because of obviously the current situation we're in. We did have face-to-face courses and we had online courses. Those face-to-face courses have now become remote live online courses, remote courses now, which I've put up on the screen for you, and you can access them straight away. I mean, there's courses every day almost, or a few courses per day, and the courses that you can attend are those listed on the top, and there's more courses coming up as well, upcoming: computing for new subject coordinators and closing the gap for outstanding primary computing for all. But the one here, the primary programming one, I would suggest really useful to go on. And also this course, this session is based on the introduction to primary computer, and if you book on that one, that will be the full course you can go on. I know there may not be secondary school teachers here, but you may be linked to a secondary school, or all through school, but you can pass on the message as well. There are secondary school courses, secondary Key Stage 3 and 4 courses, specifically for Key Stage 3. At the moment, remote course is that one on the top, Key Stage 3 computing for non-specialist teachers. And then there's 2 more upcoming, bridging the gender gap and secondary computing subject leadership as well. And you can see there, if I go back, I apologise, I need to just point out here, for the primary courses, they're absolutely free. They're free for you to attend. And also if it's one person, it's free for, if all of your teachers in your school want to attend, it will be absolutely free, but it will give one person in your school a bursary of £220. So you'll actually get money for attending one person from the school. Everyone else who wants to attend from your school can do so, and it'll be absolutely free. Secondary school is the same for that course, but secondary school also offer a CS Accelerator program. This is open for primary school pupils and teachers too. This has only been recently open, so actually you can take advantage of this as well. You won't get the bursary, but up until recently, for primary school teachers, they had to pay the amount to go on this CS Accelerator program. This is basically a highly personalised modular program to improve GCSE subject knowledge, and you have to do 10 hours worth of a course, online course, remote course, and there's an assessment. And for secondary school teachers, they would get £920 bursary as well upon completion. And if it was you as a primary school teacher, you can attend for free. I've got a few teachers of mine that I support that have attended as well and completed the CS Accelerator. What else do the NCC offer? They also offer resource repository, really great. I'm going to look into that in the next few slides. Subject knowledge, assessment, certification, and online courses as well. The resource repository, if you haven't had a look at it, please, highly recommend. Really great. There should be by the end of July a full lessons for units for every single year group from Key Stage 1 to Key Stage 4 itself. Each unit, there's lesson plans, there's slides, homeworks, individual activities, progression mapping, assessment, and pedagogy as well. There's also, this is for Key Stage 3 computing, but it might be useful for, I found some primary school teachers find it useful for them to know where their pupils are going to from Key Stage 2 to Key Stage 3. So again, there's a subject knowledge assessment for pupils. Primary certification, so if you attend one of those courses, you can actually get a certificate, but you would have to complete one face-to-face course, which at the moment there isn't, but it's replaced by remote live course, an online course, which is one of the Future Learn online courses, contribution to CAS forum. I'm going to explain CAS in a minute. Host plus one of these, host a barefoot workshop or attend a CAS communities, a practice meeting, review a resource on CAS, and one more, any one of the below bottom would be lead a session at a regional or national conference, run an after school club, or lead a CAS communities of practice. Really useful certification. You can have our numbers have gone really high, or especially during this lockdown. Your local hubs, I'm not sure if many of you are aware, there is actually up to 40 computing hubs based in secondary schools nationwide, and they provide local responsive support for computing teachers in both primary and secondary and colleges in their area. And the focal point is computing CPD, drawing on local expertise and the range of CPD, and supporting teachers from category 5 and 6 local area districts. There's actually 5 in London. I know the participants today all over the country, but in London itself there's 5, and there's so many more around England. School engagement program, I'm just going to skim over this because this is for secondary. This is but again, you can pass on the information if you are in a school or through school as well. Subject matter expert, so I'm a subject matter expert, and one of our main focus is to support schools who aren't delivering GCSE computer science, and in schools category 5 and 6 as well. We support them with action planning here. For non-GCSE, again, we support with action planning, and there are bursaries as well. And how we can support, convert and upskill, guide teachers on course and resources, curriculum intent implementation, scheme of work and equivalent, subject knowledge support, infrastructure, software support, multi-school support, raising the profile of the subject, and raising engagement of girls, and a lot more. I have also put a document in our resource document of raising the engagement of girls, because the NCC are currently, and Raspberry Pi currently are supporting. There's a program for that. Please do have a look. I've put the link in. How do I request the support? Go on the Teach Computing website, and you can click on primary or secondary there that you can see on the screen, and complete a Google Forms there to request SME support. I would definitely register as well. So CAS Communities of Practice CAS Community of Practice, some of you are probably already involved with CAS Community of Practice. They meet at least once a term. Really great place. If you go on the website, and communities across the country, they provide at least one resource for teachers attending to use in their classroom. They have a theme or topic as well relevant to computing. They also collaborate to enable teachers to collaborate on tasks and work. Really great community spirit, and opportunities for teachers to chat and network with each other. Barefoot, we used some of their Barefoot, so that crazy character was a Barefoot resource there. Again, I would really highly recommend, if you can do so, or if you haven't already, but register on the Barefoot. There's free support available from the programme, which is a central component of the NCC primary offer. And there's online courses available, linked to sequence, repetition and selection, and much more. And you can also request a volunteer or ambassador to come in and deliver a free CPD, Twilight CPD in your school, free of charge as well. Also, Code Club. Schools can sign up to the Code Club website and request support from many of the volunteers registered on their database. They're all DBS checked, fully trained to be able to deliver all the Code Club activities. And again, they come into your school free of charge. STEM ambassadors, another important and exciting free of charge resource for teachers, others engaging with young people inside and out of the classroom. You'd have to go onto the STEM website and register, and find the STEM ambassador page and register. And lots of STEM ambassadors are also registered as Code Club volunteers too. And social media wise, there's Twitter, there's a CAS chat every Tuesday, 8 to 9, primary computing coordinators face group. I didn't know this until recently myself, but there's one I've joined, but there's over 2,000 members on this. So really useful, and I found it really useful too. Other resources I'm going to share, I'm not going to go through each of them because I've talked about most of them already, but I'm going to, when we share the presentation, they're all links, so you can click on it and it'll go straight to those resources anyway, but really useful if you can and have time to go in and look through. So our session aims, identify the 3 strands of computing curriculum, considering what activities fit into each, support pupils to develop the computational thinking skills and show more competence in teaching the big 3, find the wealth of resources, hopefully, and a bit more. I've gone a bit more, I've given you a few more than the NCC, hopefully they will come of use to you. Next steps, I would definitely say look at NCC courses that build on this. Look at the Computing at School communities and forums, the primary computing courses on FutureLearn, Barefoot as well, and resources, the STEM learning, via STEM learning, there's lots of forums and advice, and Raspberry Pi Foundation have amazing ideas and materials as well, and research, really great. I think we are done. Thank you so much. I'm so sorry I've made you do lots of activities, but I hope it was engaging for you, and I think I will. There we go. Thank you all.
If you have any questions